Okay, new volunteer. Who's my new volunteer? Oh, let me get my folder here. Volunteer, volunteer, new volunteer. I don't want to have the same volunteers every time. Go ahead, sir. I'll be you next. Say again. -4, is your center. -4, very good. So the formula, right, says x minus h. It's x minus h in the formula, isn't it? But since this is a plus, that means h has to be negative. And then this y doesn't have any number next to it, so you have to imagine that it's a 0. So if this is a little confusing to you, this is really how you're supposed to be looking at this. This is off glass. Shit, I'm never going to make one. Never. X minus -4 squared plus y minus 0 squared equals, okay, who else? Do you want a new one, or do you want to do this one?
I can try. I'm not very confident in it, but I can try.
Okay, so can you tell what the radius is from this?
Would it be
9,
nine?
right? It's it's really just the square root of this number, right? So the radius here is 9. Right? This is 9 squared. So from here, do you all see this from this?
Yep.
Okay. Next one. This is your answer, right? That's it? That's your answer?
Yep.
Center, radius. All right, here's a new one. I can't really make these any harder. I mean, they are what they are. I can just try and trick you somehow with numbers, but there. Find the center and the radius. So who's up?
I'll go.
You want to go? Okay.
Yeah.
Center.
Center has to be, see, the center is -2, -3.
Is it -3?
It's a positive.
No, I don't think so, because I think because the y, like, if it was a plus, yeah, plus k, that would be something, yeah, that's definitely a -3.
Sure. So
Positive.
here's the formula, right? Here's the actual formula for any circle, right? That's our formula. So if you're telling me that the center of this is -2, -3, right? That's what you're claiming here? Then if you plug in, did you have a plus here in your formula or something? No?
Yeah.
Should be minus. Everyone double check. I did write minus on it, didn't I?
Hold on.
Yeah. So -2, if -2 went here, it would turn that into a plus. But if you try -3 in here, it'd also be plus. So I guess, isn't the moral of the story here, like whatever number you see, it's the opposite of that number? Right? So if you see a +2, h is going to be -2. If you see a -3, it's actually going to be +3. You want to get the radius?
It's square 7.
Square root of 7. And that's not a number we know, right? So we're just going to write square root of 7.
So HK is just opposite to whatever sign is in the parentheses?
Say again?
HK
Yes.
is just the opposite
Yes.
to whatever the sign
It's
is?
whatever's in here opposite. Like you can see it from here too, right? It was +4, -4. This was 0, so the opposite of 0 is just 0. So, yeah? All right. We good? Same instructions. Find the center and radius. What? What just happened?
It's not a circle.
This is a circle.
There's no
Yes.
radius.
Would you move the negative 30 to the other side?
We could move the negative 30 to the other side. Let's make our first example a little bit easier. Make this a plus. We could move the 30 to the other side, yes. Now, we have something like catastrophically different here, right? Like, think about the formula I've given you for this. It's always x minus h, right, squared plus then y minus k, and then that squared equals r squared, right? So it's always been like x with a number either added or subtracted, that squared. Here, same thing, y minus k, that squared equals r squared. I have not given that to you in this nice format, have I? So what do we do, right? I mean, the big problem is, well, let me ask you this. If this wasn't here and this wasn't here, would you be okay? You could move the 30 over, right? To the other side. And then what would the center of this circle be? 0, 0, right? If these two weren't here, that would be center 0, 0. That would go to the other side. The radius would be square root of 30. Do you all see that? If these weren't here. But they are, right? So what the hell do we do, right? Anyone know?
Factor.
I don't expect anyone to know how to do this, but I'm just curious if someone has. Yes?
Are you going to factor x's and y's?
Factor, how do you mean factor? You mean like look
group the x squared and the 2x to get.
and like pull an x out? Is that what you mean?
And then get x plus 2 in parentheses.
Let me do that and let's see if it gets us anywhere. Don't write this down, but let's just see what happens, okay? You could do this though. This is not wrong algebraically. There's nothing wrong with this step right here. Do you want me to move the 30 to the other side now?
Yes.
I can do it. I'll do it. Someone asked me. That right there is a legal step. Move the negative 30 to the other side. Add 30 on both sides. Factor an x out of these two. Factor a y out of these two. That is equivalent. This is true. This line equals this line. I agree. But does that get us to this?
No.
It doesn't, right? So what do you do? What do you do, right? Complete the square. All right, so what is completing the square? That's college algebra idea, all right? So I'm just going to preface this with, let me ask you, how many of you remember completing the square in college algebra?
I brain dumped it.
Yeah, okay. But you probably covered it. And you know what? If you don't remember it, it might actually be a good thing because it may have been taught to you incorrectly. Not necessarily incorrectly, but in a way that will hinder you if you get into Cal 2, all right? It'll hinder you because of the way it's taught a lot of times. So we're about to find out. Some of you have learned completing the square, some of you haven't or don't remember. So here's what I'm going to do. I'm going to focus right now all of my attention on these two terms, okay? These two terms. And I'm going to complete the square on those two. So I'm going to do this as scratch work on the side. I'm about to complete the square on x squared plus 2x. So if you don't remember how to do this, here's how it works. Or does anyone want to share with us how they learned it? Or are you afraid to say it now because I said it might be wrong? Or you know what to do?
I remember adding in like a 0.
Yeah, something like that.
Like a +4 and a -4.
Yeah, something like that. So what we're going to do that. We're going to add a 0 to this. But it's what is the 0 that we're adding? That's the question. So you always you always have to start by making sure that the number in front of x squared is a 1. Okay? Which it is, right? So make sure that's a 1. In this case it is. So since that's a 1, what I'm going to do is look at the number right here, and I'm going to do something with it. I'm going to take this number 2, and I'm going to divide it by 2. If this were the number 5, I would divide it by 2. If this were 8, I would divide it by 2. No matter what this number is, I'm going to take it and divide by 2. It just so happens for us that this is going to be 1, right, for us? That's our first kind of magic number. Now what we do is we take that answer, and we square it. So 1 squared is 1, and that's like our second magic number. Why do you do this? This is what completing the square is. This is the technique. All right, I'm not going to get into the theory of why right now. Okay, so now what we do is we come back over here, we write x squared plus 2x, and now we're going to add to this our hidden 0. We're going to add nothing to this equation, or sorry, to this expression. This is where, if you learn this in college algebra, this is where you might have been told to take this number and add it to both sides of the equation. We don't have an equation. We are working with an expression here. So there's nothing to add to both sides because there is no two sides. It's just this expression. Now I realize you could come back over here and try and add it like here and here, but trust me, in Cal 2, this equation goes away and you still have to complete the square. Yes?
So if it was an equation, would you then add the number to both sides?
If it was, but I don't even want you to think of it that way. It's better to always think that you're going to add nothing to this, right? You have to take Cal 2? No?
So,
Yeah, trust me, this will save you. Because later on, this is going to be stuck under a square root, and you're not going to be able to get it to an equation. That's one of the biggest things I run into with my Cal 2 students is they want to complete the square with both sides of an equation. I'm like, you don't have an equation, you can't do it. So this way will work every time.
But if it was an equation,
Yes.
is that when you would add both sides? Or you don't
But you don't need to. Even if you had an equation, you don't need to do it.
Okay.
Like, even if this was an equation, you can still do what I'm doing here, and it's still going to work.
Okay.
So I would just throw that whole idea away. So I'm going to take this and add nothing. The nothing I'm going to add is this second magic number. I'm going to add it and subtract it. I'm going to add 1 and subtract 1. That's 0, isn't it? I know it seems absurd that I'm going to add and subtract a number, but this is what's going to make it work. If you do this correctly, which we are, I guarantee you these 3 terms are a perfect square trinomial, which means they factor. And in fact, when they factor to be exactly x, and then whatever the first magic number was, which is a positive 1, right? Plus 1 squared. If you don't believe that, take x plus 1 times x plus 1 over here on the side and multiply it out, FOIL, and you will get x squared plus 2x plus 1. Okay? Guaranteed. So that's why we're doing this. Using this number, adding and subtracting it. These first 3 will guaranteed be this, using this number in here, and then I still have minus 1. Okay? With me? I'm going to replace x squared plus 2x with that expression. All that's changed here, these 2, right, became this. Now we're getting somewhere, right? Isn't this looking more like the formula? Like x minus h, isn't that looking more like it? Okay, now we need to do the same thing for the y's. Okay, we got to do the same thing now for these. So over on the side, I'm going to complete the square again. I'll leave that on the board. So I'm going to take y squared plus 4y. I make sure that I have a 1 in front of the y squared, which I do, right? I have a 1 here. So now it's time to play the game. What number am I going to get and take half of it? 4, right? So over on the side here, I've got my 4. I divide by 2. Take that number, divide by 2. That gives me 2. It's my first magic number. Then what do I do with it? Square it. And that gives me 4. That's my second magic number. Now I rewrite this, and I think I'm going to run out of room, so I'm going to just kind of squeeze this here. So I'm going to rewrite this as y squared plus 4y plus nothing, right? Plus 0. But the way I write that 0 is going to be clever so that things factor. So I'm going to do y squared plus 4y plus what minus what? Plus 4 minus 4. The second magic number is what goes here. Plus 4 minus 4. It's not minus 4 plus 4. It's always plus the number, then minus the number. Right? Always plus, then minus. If we did this correctly, then these first three terms are guaranteed to factor to be y what? Y plus 2 squared. You can either get that by knowing how to factor or just using this first magic number in here. Y plus that number squared. We still have minus 4 though, right? There we go. Now we're making progress, yes? So this is replaced with this, and then here plus this is replaced with this. Minus 4, right? But I still have here minus 30 equals 0. What now? Get all those constants together and then move them to the other side. Right? Minus 1 minus 4 is minus 5, and then minus 30, that's minus 35, and then add it to both sides. So you just get 35 on the other side. So x plus 1, that quantity squared, plus y plus 2, that quantity squared equals 35. And now this is what we were wishing it was in the very beginning, right? What's the center of this circle? Negative 1, negative 2, right? The opposite of those two. And then the radius, square root of 35. We're done. You like it? It's kind of fun, right? Let's do another one. Yeah, I think we should do another one. How are we doing on time? Yeah, we got 15 minutes. Completing the square. Can I erase this yet or no? You ready for that to go away? I don't know why, it just feels like it's already the weekend. I know it's not, but it's only Tuesday. All right. Let's go with, how about this? 2x squared plus 2y squared plus 8x plus 7 equals 0. I'd like to know if this is a circle, what is its center and what is its radius? Unfortunately for us again, we've got issues here with this 8x term, right? If this wasn't here, we might be able to figure this out, because you could almost look at this as being like x minus 0, y minus 0, so the center being 0, 0. But because of that, that's the big problem here. We can't just crank it out. So let's do what we did before. Let's collect our x's together. Put our y's together over here. So all I'm doing here is just moving this over here so that I can work with the x's. Let's go complete the square on the x's. I have 2x squared plus 8x. Right? I need to complete the square on this. The first step to complete the square is to make sure that you have a 1 in front of the x squared. We do not have a 1, do we? So what I'm going to do is pretty simple. I'm going to factor a 2 out. Okay? Do we agree that this is the same? Just pull the 2 out of here and here. Now I'm focusing all of my attention on this piece here in this parenthesis. And I'm going to complete the square on this, right? Because y'all see this is now 1. So I'm going to take what number and take half of it? 4, take half of it and get 2, right? That's my first magic number. Take this and square it. We get 4. That's my second magic number. Yeah? What do I do now? I'm going to add 4 and subtract 4. Where? Inside the parentheses. This again, those of you in Cal 2, if I see you down the road, you'll appreciate the fact that we have to work within this. You have no other equation to work with. We have to add the hidden zeros in here. 2x squared plus 4x. I'm going to even put it here, plus 0, right? That's my hidden 0 right there. I'm going to add and subtract 4 right there. 2x squared plus 4x. Here it comes, plus 4 minus 4. In terms of historically, this idea of adding a 0 to something to make things work is a very, very advanced idea. We've been doing something like it for a while. I'll give you an example. If you were trying to do x over 4 plus 3 over x, if you wanted to add those two fractions together, we would get a common denominator, right? And to do that, what we would do is multiply each of these by something, right? Here in this case, we would do 4 here, what, x here, x here? What you're doing is you're realizing next to this fraction there is a hidden 1. And you are multiplying by a hidden 1. Right? That's what you're really doing. You're multiplying by 1. That's a pretty advanced idea. You've been using it. We've been using it for a long time. This is different. We are adding nothing. Adding nothing. But it's going to make things work, right? So historically in math, this came after that, using this idea. Okay, I'm going off. All right, so what happens here? These 3, right? These 3 are guaranteed to factor, right? Now I have to pay attention to things here. I have a 2 out front. I have a parenthesis. These 3 factor to be what? X plus 2, but then that quantity squared, right? And then I still have over here minus 4. There we go. See how everything works out there? Now I'm going to do one more thing before I put that over there. I'm going to distribute the 2 through. It'll hit here and here. And I'm going to put that up here. When I multiply 2 times this, I actually can't multiply the 2 through because there's an exponent. So the 2 sits in front of the x plus 2 squared, and then I multiply the 2 to the negative 4, and I get negative 8. That is what I'm going to replace. These 2 right here, these 2 terms are going to be replaced with this. So these 2 terms right here are being replaced with 2 parenthesis x plus 2 squared minus 8, then plus 2y squared plus 7 equals 0. Any questions? Now where from here? Where do we go from here? Do we need to do the same completing of the square for the y? Do we need to? No, because we have a y squared term, but we don't have a y term. So this one actually doesn't require any completing of the square. But this doesn't look like the equation of a circle to me yet, right? So what do I need to do? We're going to need to deal with the 2 here. How about we put this number and this number together? What is it, these 2 together? Negative 1. Why don't we move that to the other side? Maybe it'll just look a little bit better for us. So what's the new equation? If I move that those constants to the other side, I'll have 2 parenthesis, right? 2y squared equals what? 1. Okay. But that's not the equation of a circle yet, is it? Because our equation of our circle is parenthesis x minus h squared plus parenthesis y minus k squared equals r squared. We've never had a number in front of this like this, have we? Here and here. We haven't had that. So any ideas on how we can maybe get rid of this? Divide everything by 2. Both sides of the equation. Right? Divide this by 2, divide this by 2, divide that by 2. So that my left side becomes x plus 2, that quantity squared, plus y squared equals a half. Are we there now? Yes, we're there. What is the center of this circle? -2, 0, right? -2, and then y squared, that's really y minus 0. And then what's our radius? It's the square root of that number, so square root of 1/2. When you take a square root of a fraction, are you allowed to take the square root on the top and bottom separately? Is that legal? Square root top and bottom when you have fraction?
No.
It is. It is. Okay, so if you ever have a fraction in a root, you can do the root of the top and the bottom separately. Which in this case, what's the square root of 1? And what's the square root of 2? Well, I don't know. It's square root of 2, right? It's 1.414 something. I'm just showing you that answer could look a couple of different ways. Yes?
So you can't have a radical. I mean, I thought there wasn't supposed to be radicals on the bottom.
That's why I did that intentionally. I wanted to ask you the same question. Is that answer okay? Can I leave a square root on a bottom like that? That's if we have a negative under a root, right? If we have a negative under a root, then you get an imaginary numbers. So I'm going to answer that question. But let's make sure we're all clear on this. Does everyone understand the idea of completing of the square? The thing that tips you off that you're going to need to complete the square is when you have, x squared, y squared terms mixed in with just x terms and y terms. When you see that, you go, shit, I've got to complete the square. All right, and then you go do it. If you didn't have this, if I didn't have that, then I would have actually moved the 7 over and then divided by 2. But unfortunately, we'd have a negative, and then it wouldn't be a circle, and it wouldn't make any sense. But I'm just saying that's what I would do if this wasn't here. I'd move that number over, divide by 2, and then I'd get my equation. All right. All right? So I believe the homework for this is due. I changed the due date. The homework for this section is due by Thursday at, I don't know. I just changed it. I think it's right before class starts. You'll have to double check. But okay, so this is pretty much the material, but let's address this question because I don't want you to get points taken off because you messed this up. Show of hands, are you allowed to leave this like this? Yes or no? So yes. No, let's do it this way. How are we going to vote? Raise your hand if you think we need to do something with this still. Like we have to change this. Only a few? So the rest of you say this is okay as an answer. Yeah? Why is it okay? I know that people have been told they can't leave a radical in the bottom. I know you have been told that. Some of you have, right? That's obviously you wouldn't be bringing it up, right? So am I allowed to leave this or not? No? You heard no, right? You've heard it's okay?
I mean, it's just a number.
It's just a number, right?
Like you said, it was at 1.14 whatever.
Yeah, it's just 1.14. So
You square it to get rid of the square root.
So let's talk about what have you been told. For those of you who've been told you cannot leave your answer like that, what have you been told you have to do with it? You have to do something called rationalizing, right? So you take this answer, they say, no, you can't have this as an answer. You can't have a root in the bottom. So they tell you have to multiply the top and bottom here by square root of 2. And what happens here is you multiply across, you get root 2, and on the bottom you get root 2 times root 2, which is 2. And they tell you that that answer is acceptable, right? For those of you who have been told this. I was told this as well when I was a student. I was told never, ever leave square roots in the denominator, or I'm gonna take off, right? So as a student, I didn't like that. I didn't understand why I couldn't leave it there, because it's just the same number, right? All we did was multiplied by 1, right? So this should give us the same answer. So if you were to get on your calculator, which you don't need to, but if you did, if you typed into your calculator 1 over root 2, you would get approximately 0.707. If you go to your calculator and type in the square root of 2 over 2, you will get approximately 0.707. They're the same answer. So again, why are you told you can't do it? I'm going to tell you why. Right? I'm going to tell you why you were told this. And it's going to take me the 2 minutes that are left in the class. Back before calculators were commonplace, 1940s, 50s, if you were an engineer, there were certain numbers you just had to know, all right? Certain numbers that you had to have memorized, like pi. We all know pi is approximately 3.1415. And the thing about pi is it goes on forever, never repeats itself, doesn't have a pattern to it. Do y'all know what numbers that do that are called? Numbers that go on forever, never have a pattern? No. Irrational. Irrational numbers. Rational numbers are numbers that either the decimal stops or there's a pattern. So that's something a student without a calculator would have to have memorized, because pi comes up all the time. Other numbers that they had to know, E. E is approximately 2.718. You learned about E in college algebra, right? And there's all these other numbers that always come up in engineering, physics, biology, chemistry, things like the square root of 2. That is something that comes up a lot. So they'd have to have it memorized, 1.414, all right? So these things, imagine, back in the day, you had these memorized. They actually had competitions. It was like a, you could show your mathematical superiority over other students by being able to memorize this further than other students. It's like, I know pi out 50 decimal places. How about you? You know? It's a serious, I'm not making this up. Okay, I have a colleague I work with right now that still knows it out 60 digits. And he at one point knew it out 120 digits. All right? Because he was raised without calculators. All right. So imagine you're back in this day and you've got these things kind of memorized, right? And you run into